Welcome on lecture series in wireless mobile communication. Uh, Before we are going to start, in previous lecture we have seen the channel equalization. So we are going to basically observe the what happened when the more than inputs are coming into multiple waveforms, and they are producing the unwanted noise in a receiver end, and the fading coefficient will also play an important role, because the channel is the most important characteristics. They are not only filtering, but they are also adding the noise. So under this uh, view, we are in previous lecture we have seen the channel equalization, or the most of the time, if we want to design a model to analyze the behavior of the channel, wireless channel. So this is the typical, you can say, general model. The output of y of k at any time t, that is represent the symbol received at time r, is equal to fading coefficient, channel fading coefficient of h, and the product of your transmitted symbol at time k, plus vr is the noise symbol at time k. So now we have the equation of y of k is equal to product of h and x of k plus vr. So if we observe this model, you have seen that the current output y of k, or the symbol, are not only depend on the your current input of symbol x of k, plus also it's depend on the others uh, others symbols which are transmitted at time r minus 1, or say r minus 2, r minus 3, and so on. So if we design for simplicity, you have seen that the y of k here is equal to component of h of naught, uh, fading coefficient, plus multiplied by the transmitted symbol of x of k at time k, plus at next jo transmitted symbol at time kr minus 1. So fading coefficient of h of 1, xk minus 1, plus noise. So if we see the this relationship of the model, the our output symbol, this k, at the time k, it not only depend on the values of this current transmitted symbol, but also depend on this uh, previous symbol of x minus k. So essentially, agar if you see this x minus k, the behavior of this x minus k, what is the impact of this x minus k when it is adding in this model? It is interfering the fairing with the current symbol at time k. So this is the you say this is the term as term as inter symbol symbol interference. interference. In short, you can say it is the ISI, inter-symbol interference. This is the condition which is, you can say, it is undesirable. Is therefore we would like to remove this symbol interference. Um, under this under this condition, this is the undesirable. So you have to remove under this condition, which is undesirable, undesirable undesirable. So therefore 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 we would like to remove to remove ISI interference. This is the uh, terminology or terms. That's why we are using the equalization before our receiver, before the receiver end. So how we are removing this ISI? Uh, why we are removing? Because uh, how we call this removing process? The answer is removing removing ISI inter symbol interference is termed as equalization. Equalization. सो फॉर दिस अब हम लोगों को करना क्या है कि इसके लिए एक जनरल वी आर कंसिडरिंग द जनरल सिनेरियो. सो वी आर गोइंग टू सी हाउ दिस previous symbol is effect on the current symbols and how we are going to remove it. So let us move for a in general in general scenario y of k at time t symbol output of this trans output of the received symbol is equal to h, then y of k is equal to h of 0 product of fading coefficient and transmitted symbol plus h of 1 multiplied by x minus next time at time t k minus 1 when fading coefficient is 2 multiplied by x k at time minus 2 and and h of l minus 1 transmitted symbol last symbol k minus l plus 1 and plus noise at time k. सो इस इक्वेशन में जो आप टर्म देख रहे हैं, जो टर्म आप फेडिंग कोफिशिएंट देख रहे हैं, एक यहाँ पे है एच ऑफ नॉट, एच ऑफ वन, एच ऑफ टू, और दिस इज द एच एल माइनस वन. So these are nothing but this is the L channel tap. It is known as H naught, comma, H1, comma, H2, comma, and H L minus 1. So this is a ये कहलाएगा L channel tap. So conclusion is कि जैसे जैसे L बढ़ेगा जैसे जैसे as L increases, as L increases, the severity severity of your SI increases. हम जब जब कोफिशिएंट्स को उसको और बढ़ाते जाएंगे, एक्सपेंड करते जाएंगे, तो प्रीवियस जो सिंबल है वो आपके करंट उसके करंट सिंबल पे उसका इफेक्ट पड़ेगा, जिसकी वजह से इंटर सिंबल इंटरफेरेंस आएगा, और यही जो इंटर सिंबल है ये बढ़ते चले जाएंगे, जिसकी वजह से हमारा सिग्नल्स डिस्टॉर्टेड हो जाएगा एम्पलीट्यूड और फेस में, क्योंकि बैंडविड्थ जो कोहेरेंस बैंडविड्थ है वो कम हो जाएगी, चैनल की जो बैंडविड्थ है वो सिग्नल की जो बैंडविड्थ है चैनल की बैंडविड्थ बढ़ जाएगी, तो चैनल की बैंडविड्थ बढ़ेगी तो इसकी वजह से जो सिंबल्स हैं ये और क्लोज एक दूसरे के आ जाएंगे, टाइम डिस्पर्शन फिनोमेना हो जाएगा, और सारे के सारे सिग्नल्स एक दूसरे पे इंटरफेरेंस करने लगेंगे, करंट करंट जो सिंबल है वो प्रीवियस सिंबल को ऑक्युपाई कर लेगा या ऊपर लेफ्ट कर लेगा. दिस इज द केस ऑफ ISI इंटरफेरेंस. सो अब क्या होगा कि जैसे जैसे ये हम अगर इसको देखें, तो अगर फॉर इक्वलाइजेशन की तरफ अगर हम बढ़े, तो यू कैन सी हेयर फॉर equalization for equalization of transmitted symbol at time k, x of k, with L is equal to let you say L is equal to 2. So let us employ चैनल टैप, हमने 2 लिया है यहाँ पे, 1 और ये 1, ये हमारा 2, खाली इतना ही हमने L लिया है, ठीक है। और इसको हम एम्प्लॉय कर रहे हैं, तो क्या होगा आइए देखते हैं। तो अगर जब L इज इक्वल टू 2 है तो इट इज स्टार्टेड फर्स्ट, L टेक्स द वैल्यू 0, 1 and 2. Now you having this one and this one. So y of k transmitted symbol at time k plus 2 comma y of k plus 1 comma y of received symbol at time k। ये कैसे मिला है एक बार आप देख लो कि आई एम पुटिंग द वैल्यू ऑफ x k माइनस l प्लस 1, ठीक है। वी आर एज्यूमिंग tap channel tap is 2. So first of all we are taking the values of 0, so inserting this value L 0. Now what is the our transmitted signal at the time of k plus 1, ठीक है। So our k value is k plus 1। when L is 1, then x of k minus 1 plus 1, this is cancel out, we are getting the x of k. So the received symbol at k, the received signal at k plus 1 when L is 1, when L is 0, और ये हमको मिलेगा when L is 1, ये हमको मिलेगा। Now taking the value of L is equal to 2, so x k minus 2 plus 1, how much, कितना हो जाएगा, ये हो जाएगा y of k plus 1। y of k plus 1। So इधर we are taking these values, or you can see here this the tap R. The R is the tap equalizer. R is the tap equalization. So here R is 3. This is the tap, you can see. This is the tap equalization which is denoted by R. Value 3 है, so R is 3. Or we are also having L. L is the your channel tap. तो channel tap is 2, जो रिस्पॉन्स है, और ये आउटपुट है, ये टैप इक्वलाइजर है. तो अगर हम इनको इम्प्लीमेंट करते हैं तो होता क्या है कि जैसे जैसे एल टैप इंक्रीज करेगा तो मेरा ये भी इंक्रीज करेगा, इसीलिए वी आर गोइंग टू सी व्हाट इज द positioning of under this equation. So you have to write here with the help of y of k is equal to h naught plus x of k plus h of 1 x k minus 1 plus v is equal to noise of time k. So if we change this stage, अगर हमको उसको लिखना है कि इसके किस फॉर्मेट में है, और हम देखें कि क्या फर्क पड़ रहा है, तो हम इसको इसके फॉर्म में लिखना चाहते हैं. ठीक है, तो हम कैसे लिखेंगे ये देखिए. सबसे पहले हम क्या करेंगे, दिस इक्वेशंस को लिखेंगे. नाउ we write first of all R is equal to h naught x of k at time k plus h of 1 plus x k minus 1 plus v of k. और हमको लिखना है इनके सिंबल जो टैप्स हैं, जो आर इक्वलाइजर टैप्स हैं, ये y of k plus 2, y of k plus 1, y of k. सो पहला y of k क्या होगा, सिंपल, इट इज h naught x of k at transmitted symbol at time t at time k plus h of 1 x k minus 1 plus vr. ठीक, जब टाइम k की जगह k plus 1 लिखेंगे तो क्या हो जाएगा, y of k plus 1 इज इक्वल टू, जहां जहां k है वहां k+1 लिख देंगे। ठीक, दिस इज k की जगह वी रिप्लेस k+1 प्लस h1 k प्लस v k+1. Now y of symbol at time output at time k+2. So you can write h of naught x की जगह k की जगह यहाँ पे हो जाएगा k+2 प्लस प्लस h of 1 k k+1, ठीक, प्लस नॉइस k प्लस, ये 3 इक्वेशंस हमको मिली, स्टेजेस 3 मिले, और इसको हम मैट्रिक्स फॉर्म में कंबाइन करेंगे, लिख सकते हैं। तो अगर हम आउटपुट के फॉर्म में इसको मैट्रिक्स के फॉर्म में अगर लिखें तो ये होगा मैट्रिक्स, ये वाली रो लेंगे y k+2 y k+1 y k, द आउटपुट मैट्रिक्स के कंबाइंड करके। तो अब इसके कोफिशिएंट के लिए h h1 0 0 0, h of naught h of 1 0, तीसरा वैल्यू 0 और ये भी 0, और यहाँ पे आएगा h0, यहाँ आएगा h of 1, और इसकी जो वैल्यू है ये हो जाएगी x k+2 मैट्रिक्स के फॉर्म में x k+1 ये हो गया ट्रांसमिटेड सिंबल मैट्रिक्स प्लस नॉइस v of k+2 v of k+1 v of k, इसमें कितनी रो हैं, 1 2 3, 3 रो हैं, कॉलम कितना है 1, तो r×1, और r कितने हैं इसमें वेटेज 3, तो ये हो गया 3×1 का मैट्रिक्स। अच्छा, इसमें x ऑफ जो मैट्रिक्स है, जो ट्रांसमिटेड सिंबल मैट्रिक्स है, इसमें कितनी रोज हैं? इसमें रोज है x+1, k+1 और r के x ऑफ k-1। एक एक करेक्शन है, ये है x ऑफ k और इसके ठीक प्रीवियस है x k-1। दिस इज द ट्रांसमिटेड मैट्रिक्स। हेयर कितने इसमें रो हैं? 4, 4x1। अच्छा, और कितनी इसमें कॉलम होंगे? एक एक कॉलम है, सो ये r+1 प्लस l-1, तो r+l का है ये, ठीक है। टैप कितने हैं उसमें? 8। जो r टैप है 4 है, 3 थे, एक बड़ा, 4 हो गए। और जो आपका चैनल टैप था, जो चैनल का टैप आपने बनाया था H0 Hb, वो l-1 नहीं है, ठीक है। सो अब ये जो मैट्रिक्स है, ये मेरी H मैट्रिक्स है, H मैट्रिक्स। और इसमें क्या है? R क्रॉस, ये है r+l-1। सो r इज 3, जो मेरा सिंबल्स है 3 है, और जो मेरा r है 3+2, 3+2 यहाँ पे रखिएगा, 3+2 कितना हो जाएगा? 3+2, ये है आपका r, यानी 3+2-1, 4 क्रॉस, ये है आपकी वैल्यू 3x4। ये है r×1, r की वैल्यू 3 है इंटू 1। दिस इज डोनेटेड बाय y, var of k, this is h, this is donated by x, bar of k, this is v var of k. So now we have to write the equation. After this, y of bar at time k, this is the receiving symbol, this is the response of the channel x matrix x, this is the transmitted symbol at time k, plus v bar noise, additive noise. These are the matrices. Now see, a received symbol having the matrix r×1, and response of the channel having the matrix R cross L minus R cross L plus L minus 1, and x of uh, k bar, it is the transmitted symbol. The matrix is R plus L minus 1 cross 1. Noise of the channel is additive in R cross 1. So let the equalizer weight be C naught comma C1 comma C2. Then we have write the matrix C is equal to C naught, C1 and C2, right? So this is the called equalizer vector. Equalizer vector, and it is the R cross 1. R tab value is 3, 3 cross 1. Now equalizer is given by R is given by coefficient of C naught, weighted linear combination of this R y of k plus 2, received symbol k at time k plus 2, k plus 1 and k. So not product of weight multiplied by the transmitted received signal at time k plus 2, weight of C1 multiplied by linear combination के हिसाब से y of k plus 1 plus C2 y of k. So this is the weighted linear combination of y k plus 2 comma y k plus 1 comma y of k. So this is the weighted signals Now, what are the how the equalizer look like? So check it out. X of k is the y of k is the this is the received symbol, or you can say waveform, received waveform. So conversion is taking place low frequency to high frequency, which is the frequency down phase conversion. After that, it goes to the receiver, receiving filter, receiving filter. Then it's passed through. If the coherence bandwidth is larger than as compared to the channel signal bandwidth, so all the components of the transmitted signals are passes from the pass filters. So it is also passing from the receiving filter. But if there is any inter symbol is occur, so under such a circumstances, the amplitude and the phase, the distortion is taking place, so we need a equalizing filter. So here we put the equalizing filter. So here is a one switch, like this way, and here is a one block where we put this some threshold. Because all the signals is depending on the time dispersion. So we need a threshold for the comparison of the our reference value to the transmitted signals value. So this is the step, और ये कहलाएगा डिसीजन मेकिंग स्टेप्स. Decision making. Now now We put this in a block. We take the equalizer inside this section, making a full block. So this receiving filter output are depend on baseband, pulse, or possibly distorted. So at this point, we having the baseband pulse. And the switch which have here I have put, this is the sample of the equalizer, where all the symbols transmitted are tested, test, statistical way, statistic analysis, and and the frequency down conversion is used, the filter band pass. Band pass signals. So at this moment, from here, demodulation, demodulate, and demodulate and sample or symbol. This is the major step, so it is called the step 1. The waveform to sample or pulse or symbol transformation. This one is the steps to decision making. So For equalization technique, which we are using here to multiply the our corresponding signals towards the previous signals, and we are getting the our actual output of the signals. So we need this technique in a field of you can say linear equalizer or non-linear equalizer. So the most of the linear equalizer are common type of this channel equalizer. So you can write here the most simple and this is the diagram of equalizer. Equalization, complete picture of equalization. So we are going to types of the equalizer. The most simple and common type of is a channel equalizer, which we already seen, and it is used in a practice, जो आज भी हम लोग इसका यूज करते हैं to reduce the ISI is a linear equalizer. The linear equalizer is implemented on FIR filters that also known as transversal filter. The linear equalizer can be implemented as an FIR filter, also known as known as transversal equalizer or filter. So in this equalizer, the current and the past value of the received signals are linearly weighted by the adjustable filter coefficient and sum up to produce the output of this. And the output of this is given to the following figure. In this equalizer, the current and past, you can say previous or past, current and past values of received signal are linearly weighted, linearly weighted by the adjustable filter adjustable filter coefficient and sum up to produce the output. ये चीज मैंने अभी पिछले ही इसी लेक्चर में उसको वेटेड करके और आई इक्वल टू 2 करके आपको दिखाया है कैसे उसको वेटेड करते हैं, लीनियरली कैसे आता है और क्यों वेटेड होता है, क्योंकि इट प्रोड्यूसेस द एलएसआई आईएसआई. सो output, sum up to produce the output, you can say it is uh, as shown in the figure. That figure is figure which is shown below. नो ये जो फिगर्स हैं हम वेटेड जो सिंबल्स लेंगे ये डिपेंड करेगा कि कितने वेटेड हम ले रहे हैं. यहाँ पे हम इसको दूसरे ढंग से दिखा रहे हैं ताकि इसको आप समझ सकें. दिस इज दी आवर z-1. Here we applied the input y k plus n. This is the E minus N1 here, E minus N1 plus 1 and the output of Z bar K plus N1 minus 1. So this is the our input signal, right? So these are the weighted value that are should we sum up. So here we are going to sum up the output of this, also sum up, and is followed to the next. This is Z bar and output of is y of k at time k. This one is the E star E naught symbol signals. This signal is sum of here, it coming from this direction and goes here. Now making a cascade chain, another weighted signal going this side, Z minus 1. This is the another block. The output of this K minus N2 plus 1 and drop the line here. E the value of this signal N2 minus 1, and it is the again sum up of goes to the next one. This is the delta dk, the small one delta is referring, if it is less than this, there is a no distortion. If it's greater than, then distortion will be taking place. N minus 2, the output of this transversal equalizer filter is coming in this block, or this is the like this. So output is d of k after the recreation of and comparing the threshold detector. So this figure is the structure of Structure of linear transversal equalizer. So the mean square error the minimum mean minimum minimum mean square error that a linear equalizer equalizer can achieved is is E mod E की power n mod का square bracket close the time interval of t upon 2 pi and the limit is pi by t to minus pi by t not f e की power j omega t a whole square plus unwanted noise the second thing is the non-linear equalizer non-linear equalizer basically non-linear equalizer are the two types. One is the decision feedback feedback equalizer which is given by T F E and second one is the maximum maximum likelihood sequence estimation. So, the non-linear equalizer are used in a application where the channel distortion is to serve for a linear equalizer to mitigate the effect of the channel impairments. The reason for choosing the non-linear equalizer over a linear equalizer is that the performance of the channel that exhibit null is not effective. So the noise enhancement in this region and long impulse response are the problem. So basic reason for this problem is the linear filtering a noise or process together, which is causing the noise enhancement problem. So this is the today only. Today in this lecture, we will see more detail in a non-linear equalizer under the heading of decision feedback equalizer. Till then, bye. Thank you.